I still have a very vivid memory of the first time working in casualty as an intern when a patient was brought in dead on arrival, and a 29-year-old mum who'd been perfectly fit and healthy up until that day and left behind 3 kids and obviously a grieving family. And I can still remember the image that sticks in my mind is her husband being brought in and being explained, being told what had happened, and you could just sort of see that expression on his face of why, how has this happened, what's gone wrong. I'm Jamie Vandenberg. I'm currently the Co-Deputy Director of the Victor Chang Cardiac Research Institute, which is where I've worked for the last 20 years. My research focuses on the molecular and cellular basis of cardiac arrhythmias, and specifically looking at the ion channel proteins that regulate electrical signals in the heart. And we're interested in trying to integrate all that information to understand how you go from molecules up to integrated electrical activity at a whole heart level, and then to understand why does it sometimes go wrong in patients who develop cardiac arrhythmias. During my medical school days, I was particularly interested, or I found cardiology particularly interesting, and I think I could probably put that largely down to David Kelly, who was the Professor of Cardiology at the time, who ran a series of fantastic tutorials. And it really gave me a sense that if you really understood how something worked, you could develop a much more rational way of treating patients and treating disease. Whilst I enjoyed clinical medicine, I think I always had an interest in doing research. And I was lucky enough to be given the opportunity to go and do a PhD overseas in Cambridge. Cardiac electrophysiology, in a way, at the time was the sort of big unknown. It was the one that was hard to treat. We had, they started to develop stenting to treat coronary artery disease. And there were some new drugs coming on the market for heart failure, but cardiac arrhythmias was really the next frontier, is the way I saw it. And I suppose in a way I really sort of fell in love with the idea that you could actually see individual molecules in action, and you could actually see these channels open and close and understand how molecules were working. And then around about the year 2000, by that stage I was married, I had 2 young kids, and the decision had to be made in terms of whether I was going to take on a faculty position in the UK. But actually the fact that the Victor Chang had been set up, it was back in my hometown of Sydney, and it was an institute that was dedicated to really fundamental basic mechanistic studies into cardiovascular disease, which is exactly what I was interested in. And it brought all those people from heart failure, from coronary artery disease, the whole gamut of cardiovascular disease, but all in one location. And I've been here ever since. From a scientific point of view, I'm particularly proud of the study that we did using a technique that we call REFA, or rate equilibrium free energy relationship analysis, to really understand how the hERG potassium channel works. I had a couple of really fantastic students working on that project, and that was a really sort of fulfilling time, sort of training students as well as doing some exciting and interesting biology. I'm also proud of the contribution that I made to the CEPA initiative, where I think the next sort of 5-10 years of my career are going to be focused perhaps more on making sure that that next generation of researchers, the students, the postdocs, get the maximum opportunities that they can to flourish and become independent researchers by themselves. It's part of giving back to the community that supported me so much over the last 20 years, certainly here in Australia, and being able to sort of mentor some of those younger people coming up and explaining to them why it is such an important area to work in, but why it's also sort of fascinating and interesting and exciting, and such a great community to be part of.